Hello, welcome to Dev Radio. I am back with Microsoft Azure developer influencer Jagadish, who is joining us. He leads a really interesting team at Marsh McLennan, Cloud Center of Excellence. And today he's got a couple of members of his team here, Sridhar and Kasim, who are going to be talking about some really interesting stuff they do with Azure Data Factory and its integrated runtime, moving large files around. Um, Lots of stuff to learn from you guys today. Jagadish, why don't you go ahead and take it away and introduce your team?
Thank you, Matt. Glad to be back here. This is my second session with Matt. Check out my session on API management and some of the best practices and how you can achieve greater security, cost efficiency. We'll probably post it as one of the link. So I'm here with my colleagues, data architects, Mr. Sridhar Yadula and Mr. Kasim. We call him shortly because he got a long name, right? They are here. I am probably with along with them, along with the Matt, moderating some of these sessions with them because they are the experts on Azure Data Factory. We have been utilizing this for quite some time, and we have some interesting use cases to share where we I think we pushed the limit on ADF some of these things. So why don't we start with a quick introductions? I'll start with Sridhar and then Kasim, and I'll probably have a quick introduction about myself and then turn it over back to Sridhar. Sridhar, why don't you quickly start?
Yeah, hi. My name is Sridhar Yadula. Basically, I'm a I'm a data architect at Guy Carpenter. So basically, this one comes under MMC, and we do like reinsurance brokerage, and we place business with our clients. And I've been working here for the last 7 years, and basically, I oversee all the data related activities within Guy Carpenter. Yeah,
Thank you,
go ahead.
Sridhar. Kasim?
Hi, Matt. So nice meeting you. I joined Guy Carpenter back in 2023, and it has been very exciting working with this team. LFU is one of the projects that we're going to talk about. Like Sridhar, I'm his counterpart. We both work on the data centric projects. We're working on placements, which he just talked about. Because of the reinsurance business, we have a lot of clients who wants to upload information, exchange data across, and all that. So sometimes very challenging use cases that we get. So every day there is a learning, and it's exciting journey so far.
Thank you, Kasim. Again, myself, Jagdish Kantraj. I'm one of the enterprise solutions architect in MMC Tech, working closely for Guy Carpenter Solutions. As Sridhar said, Guy Carpenter is a leading reinsurance broker. We work with clients, we work with markets. Insurance companies are our clients. We diversify their portfolio. We grow their portfolios profitable by diversifying, working with markets, as well as we do lots of analytical services solutions on top of it. Check out our link guycap.com, our link mmc.com. It will be there in the video, some in the description of the video. As I said, we live in an interesting time. Technology, as if, is eating the world, as they say. Uh, we get to work on it. That's the exciting part, and we have done some pretty amazing stuff on Azure. Um, uh, and here today we are going to talk about the Azure Data Factory, as I said. So sit back, relax. There are some best practices and some sort of limitations which we saw, and then there are some very unique use case which we got an opportunity to solve, which ADF was one of the outlier. So we're here to tell a story, how we saw an opportunity and how we solved it. So Sridhar would start with it, and then Kasim will go into some specific use cases on the Azure Data Factory. So Sridhar, take it away.
Yeah.
Thank you everyone for listening again.
Okay. So, any questions, Matt, or I can go ahead?
Well, yeah, go ahead. I mean, just start with what was the problem you're trying to solve? Maybe we'll start
Okay.
there.
So
Yeah.
basically, I think we started our journey, cloud journey, like 7, 8 years back, and we had multiple software, multiple systems, and mostly we were using Power Center, which is Informatica Power Center. move data. And after that, we also tried IS. After that, we also tried IICS, which is Informatica Cloud platform, to move. Then our Azure journey started. Within that, we started looking at like ADF. And so basically, ADF has two components. One is like an orchestrator. The other one is the data flows, which will do the transmissions and everything. Basically, we were only using the first part. We only push the data from one source to that target, but we are not going to do any. So, like, we are not doing any transmissions with that ADF as of now. And once we move the data, basically we have like other tools to do the transmissions and like ingest the data into that target. So that is the high level thing. And
So,
what
Sridhar,
we
why, I mean, if I may, why did we not use the ADF transformation logic? I mean, is there any reason specific?
Yeah, I think basically before our journey into ADF itself, we had Databricks, and which was heavily used for transmissions. Because of that, we couldn't explore the ADF capability. It's not we did not even look at that level itself.
Okay, thank you. So, I mean, definitely ADF has, as the ADF is a, as they say, ETL or ELT, extract, transform, load, or extract, load, and transform. Both can be done. It's just that in our use case, we tapped into some of the other Azure resource like data fact, data breaks to do
Yeah.
that, and then we using the ADF for the core data movements between the systems.
Yeah.
Yep. And so basically what we did is that within our journey, right? So first we took one project, and we were able to move the data. So most of the data we moved it into the Azure blob storage and like ADLS Gen 2. So basically we connect to SQL Server and we get all the data and we ingest it into ADLS Gen 2. And we use CSV and RK formats, so that it is easy to consume, as well as basically it is a compressed set, so that even the sizing will also be appropriate on the storage account. Okay. And then basically we also have machine learning use cases wherein a client sends big files. And so this one is not the one what Kasim is going to talk. Basically, this is a separate use case for the analytics. We get big CSV files, and using ADF, we move that data into the blob storage. So that is also one of the use case we had.
Yeah.
And recently, what we started doing is basically we started using MongoDB. And so now basically we want to move the data from a SQL Server to MongoDB. So there we found certain issues because of the driver is not that matured within ADF. MongoDB exposes a driver which is not that mature, and we reached out to Microsoft, and they said that we need to work with MongoDB. When we reached out to MongoDB, they said that we need to work with Microsoft. So that's how we couldn't do that one with ADF natively. So what we used is we used the other technologies, like within Azure itself, like we used Azure Functions, and durable functions also we used. And within that, we were able to write all the code, and only call that function from a ADF. That is the use case also we worked on.
So in that sense, the ADF is still being used as an orchestrator, which all comes with all ADF being a platform as a service, comes with all that retry, error handling, notification. All those best practices are still there. So we still use that as an orchestrator. It's just this some of this heavy lifting where we saw limitations. We just taken that into a separate component and deploy that into a function and then calling that function from ADF, right? Sridhar?
Yes.
Got it. Yeah.
Okay, and a couple of things what we observed is, even within ADF, right? If I want to send an email, basically once my job is completed, I want to send an email to email to a group or email to an individual. There is no functionality right now. So I think they ask us to use the logic app and all those things. But if there was something like that, it might have been very much helpful for us. So
Yeah.
that is one of the limitation what we saw. And also, I think when we started using ADF, basically we wanted to use the ADF at an enterprise level. So basically, we had one instance of ADF which was used by multiple projects, and at that time we thought everything was okay.
Mhm.
And basically, when this ADF instance has grown with like many jobs and things, and different projects wants to release their code to production at some point of time, which because basically if you don't follow a proper release life cycle within ADF, that means if you are working on the code also, it will go to production. So basically there is no way you can do a release without pushing all the ADF components which are there in Git. So I cannot pick and choose and move the data. So that is one of the issue we saw. And now as so to come to get around that one, so now what we gave a recommendation is that every project has to have their own ADF, so that there won't be any like conflicts between each project. And they have their own Git repository, and they can follow their own release life cycle and push the data to push the code to
Here is
production.
that
Yeah.
So that is
uh, with ADF you can still do all the development practice like trunk based development. It's just that if you have too many teams, it becomes very difficult to manage it, especially the releases. So we
Mm.
recommend going with a particular functional team having one dedicated ADF for it.
Yeah. Yeah.
okay. And one of the issue also what we saw is global parameters, right? ADF uses global parameters. I think there are some set of limitations on global parameters, so you cannot cross certain after certain limit, it will not allow you to put a new global parameter. I don't remember the exact number, but to get around that one, basically, if you are doing a parameter within the ADF, what we do is that we define it in a file instead of defining like okay, within my job I want to define 10 global parameters, right? So instead of defining at the global parameter, we only define one global parameter, which is the blob file, which will be a storage account, right? So now when you go into that storage account and when you open that config file, you define all the project specific variables within that one, so that whenever ADF wants to get those values, first it will read from that config, because it knows where the blob is stored because of one global parameter. And after that it can read the rest of the variables from that file itself. So that's how we got around that issue. And now our new recommendation is that anybody whoever wants to create a global parameter, so basically they have to go with a storage account file and only define the global parameter at the storage account. At the basically within that global parameter, you will only define the storage name.
Yeah.
We're using the same for the LFE as well.
Yeah, yeah.
It's from the issues that Sridhar faced, I was always able to go with and take care of those things. I think we had one limit as well. When we started off, we had like not more than 40 activities. So we had hit a ceiling, but then we saw the documentation. We cannot exceed beyond 40 activities within a mapping or pipeline.
Let me share
Uh-huh.
my screen.
Yeah. So I think next up we're going to get over sort of the unique use case that you had.
Mhm.
Yeah. I think Kasim, you can take over.
Yep. So one of the major projects, I should say, a multi-year project was about placements within the reinsurance business. So we were revamping the entire solution, and it had been a big request coming from the CIOs and the CIO of the CIOs, like for the entire MMC. So there was a great push to have the solution, and there are a lot of moving parts to it. So if we speak about on a high level, the definition is very simple. The clients and the markets, they come, They want to do reinsurance for the insurances that they have. So on one side you have the clients, the other side you have the market. Our platform helps us marry them, handshake, and get the deal done. Looks very simple, but there's very a lot of complexities involved in. So one of the components of these action of having these placements done is uploading the documents. So you have documents ranging from different sizes, but then there are documents which are more than 800 MBs or GBs, or so we
Yeah.
were having 800 GB was what the defined size or the volume, that this is going to be a large file. And how do you move that? How do you make that available to the clients and the markets? So one of the biggest challenge was to have that data come in, the information about the file and the file itself. So there were a lot of different solutions, as Sridhar also mentioned earlier, that there were different ways we were doing things. But for this particular uh, problem, we had to solve in a way, because it was not just one of a case where you get a file once a week or once a day. There are many clients and many markets working at the same time, so it had to be high volume, high velocity kind of a scenario.
Yeah.
And not just that, we have it on multi regions. So we have regions like NASA, EMEA, APAC. So anybody from any region could be uploading.
Mhm.
We had to also make sure that there is data residency is being considered, security, and all those aspects that we'll talk about. So if you move forward on the next slide, we'll talk about, we just talked about the use case, what it is. So we wanted to have the clients upload the files, and then we want to be able to download that. So not just upload but download. The way the whole solution work, that's the next part, is that when the users come in, or the business users come in and upload the file, we are having a security layer where it gets the tokens and all, and that gets authenticated, and then there is authorization that happens. There's a handshake that happens, and then they're allowed to get into the system and upload files. So once a file is uploaded, there is a metadata related to that particular file that needs to be captured. Now when that's captured, we call it, saying that you are uploading it, so we call it like a web status. So it's still from the users and it's not still downloadable. So we have a metadata where we call, you uploaded a file X, this is for this client, a lot of metadata that you have, and then we allow them to upload on the Azure blob storage. So we have the way we wanted to work it out is, we have a transient storage, and then we have a permanent storage. So the transient storage is the one where they upload the file, capture the metadata, it stays there, and at a particular cadence, we wanted to move that. Now, if I go back in time and see how we reached to this particular solution, was we wanted to make sure that as soon as the file is uploaded by the user, they should be able to download, right? We don't want that a file is uploaded and then you wait for 5 hours, where's my file? So that's one of the challenges that we had, right? So initially we had a concept where we move the file as we go, and I'll talk about the cost optimization and performance and all those coming in. But this was one of the problem that we had, and how do we make the users, empower them that you uploaded your file, now you're able to see it. So the transient storage, we made it open. As soon as it's uploaded to the transient storage, the users are able to download or see the file right from there. We don't wait for the file to move. Now, the file movement, which we started initially, was at a very high cadence, kind of every minute we were executing. There is a cost to that. So every
Yeah.
minute, as in like 60 minutes. So there's a lot of throttling happening, and then you would see all the pipelines are stuck and all. They're not able to move. There's a lot of consumption of power that you see on your IRs. I'm going to talk slowly about that as well. We have a deck where we talk about why we use our local or our own VMs versus
Mm.
the auto resolve provided by Microsoft. So there's a huge difference between the two, and how we came to that approach. So we solve the problem from having the users upload to download at the same time then the upload is done, because we don't want them to wait. So the number one was uploading file and then downloading file. So we have provided tokens and stuff, security and all that around that. The mode of movement of the file is also all secure. We have put all that. That's number one. If you fail that, then the solution is no good. So secure movement of file, that's taken care of. Once the file is uploaded, there is a scanning that happens on the file. So if the file is not good, the file gets quarantined and it's moved to a secure location, so that it's not corrupting your own storage or the users or clients. It doesn't spread. uh, the next point is about the multi region we just talked about. We had some edge cases around this file movement. So when you do a placement, let's say, Matt, you are from the UK, but you are traveling to New York. When you upload your file, you could still use the infrastructure from the northeast region, the NASA region. But when you upload the file will contain the metadata which will inform our solution that, hey, this file is from the EMEA region, so you're supposed to store it in EMEA. So your data residency is being taken care of over here. So that's how the file is good. Once you upload the file, it knows this is the region. It goes and uses those resources and stores in that Azure location. So it's secure. So when the download happens, anybody is going to be in that region to download, they can easily download from that region. So that's the multi-region that we have taken care of. And any sensitive data and all is all masked, and also we make sure that there is no leakage of any kind. And then we have our own homegrown data document management system, which we have. So any file that is uploaded has information about the file, and the way we upload the file, there is an algorithm that we use. So the link that goes in is in an encrypted format. So the link that you get actually has information about the metadata. So if you decrypt it with the logic, you are able to see what is the name of the file, what is. So we have all the information. If you want to do a data reconciliation, or you want to know what file is this about, so we configure all of that onto our solution. If we can hit next. So that's the use case. It's all about. It's a very unique use case where we are moving.
And those are 5 big requirements. That's not.
Yeah, and
Yeah.
all of them had to be met, because if you
Yeah.
fail on one, maybe Jagdish, you want to add something on that, because he's more on the security and on the cloud side. He's very, very particular about any data movement that happens. But these are the capabilities. I think, Jagdish, you're on mute.
You're still on mute too.
Yeah.
No, your microphone's on mute.
I just said, I think carry on, because I'm sharing the screen, so I didn't want to do.
Oh, okay.
Carry on.
Yeah. So the next slide, we're going to talk about the blue one. Jagdish, if you can go back. Yeah. So we'll quickly give you an overview what all we have accommodated in this solution for the large file upload is. We identify the file. So let's say, Matt, you upload 5 files, Jagdish uploads 100 files, and Sridhar, and you guys are all from different areas. One from EMEA, one from APAC, one from NASA, all the 3 people from different regions, and uploading hundreds of files. The solution actually identifies the region. As I give you an edge case where a person from EMEA is traveling here, or from an Australia person is traveling to the Europe region, they can still the solution can still identify the files, where are they from, what is the region that they belong to, and they are moved to the respective regions. So identifying the files, detecting the region, and then moving the file to the relevant storage, because we have storages like web and app storage that we call. The transient storage is the web storage, and then the final target is where we want to have the file reside, kind of for a long time of retention. And then once that file is moved, we make sure that the metadata is updated. So once the file is moved, we stop the users from downloading it from the transient storage. And now, as the information is updated in the data document management system, it provides a link. When you hit the link to download, it will pick from the target storage. We have done a lot of exceptional handling and also retries and all those things. So in case if the file movement doesn't happen or a copy doesn't happen, there is always a retry 3 times, and we've tested it rigorously. It always works. So we have not left any room for failures and all. Then we have email notifications for success and failures. Majorly, mostly people look for failures or any issues that happen. So we have our own team that build notification service that we use. So whenever there is any kind of any anomaly or any issue, file movement didn't happen, there was this blockage on the execution of the pipeline, you would get an email notification with the information on the pipeline, the ID of the pipeline, so the support team could directly go into the monitor and see what exactly happened and do a restart on that. One of the other capabilities is that, let's say everything moved fine and it's been like a month. Now you don't need those files in the transient storage. We don't want to keep them there because they're already there on our target storage. So there is a process that runs every month on the last Sunday of the month, and it wipes out and calculates the last 30 days, and then it cleans up all the files from there. And above this, if every the last one is about parallel execution. So if three of you from different regions, when the pipeline kicks off, it takes files from all of you, and then the file movement happens at once. Now, we'll go into the actual solution, and then we'll talk about the performance and then the cost optimization and all that we did. So this, on a high level, is the pipeline that we were just talking about. So we have an Azure key vault that we use. So the key vault is where we are storing our secret. So at the beginning of the execution of the pipeline, it looks for the secrets. Once the secrets are procured, we go for the token. So that's the security level that we have. Then the token, as Sridhar was talking about, how we are having the global parameters and the config files and all. So we store all those information, all the links for the endpoints and all is all in a config file. So it picks up from, let's say, for the Okta authentication, we have a dedicated endpoint, private endpoint, where it picks the information using the secrets from the key vault, and then the authentication is done. Once it's in, then it will go next to get the tokens for each region. So then it gets the token for EMEA, NASA, APAC, and then moves on. The third one is where they go and say, okay, now I look for the files. Do I have file or no? So let's say you are the person responsible, or you consider yourself as group of companies for EMEA region, and then the solution is going to look for any files are there for EMEA or no. If it's not there, I would just exit it. I would not execute that particular routine. So I'm out. There are no files from EMEA, I don't do anything. So that's right there, I'm doing an exception and I just move out. Then I come to NASA and APAC. If they have files, I'll go to the next step, which is nothing but there's a loop, for loop. So if, let's say I have 100 files, I will execute all those 100 files for that region, and it'll be all in parallel. So there is an option in ADF that says, do you want to execute sequentially or in parallel? So we choose parallel so that every client is important to us, right? So we don't want to have a preference of one client over the other. So we move all of them at once. And if, let's say, APAC and all of them, they have 100 files, all of them will run in parallel. And that's where we will trying to use the power of ADF, which we'll talk about shortly, which is the heart of the solution. So once it goes in and runs parallelly, each region is being picked up, whichever region it is for, it moves. That's the last part, which is the switch part. So that's where it detects, and then there is a copy activity that does the movement of the file, picks the file from the transient storage and moves on to the final storage. After that, the next step is it updates the information in the document management system and says, hey, the file is moved, everything looks fine, this is the location, go and pick the file from there. So that's what it does. There's a lot of nuances and all that goes into this. There's one more thing that we do is, let's say we had outage on the cloud, which we did, I think, a couple of days ago. So let's say we missed the window. What do? There will be an email that goes out. It says, hey, you had unprocessed files. So in that case, you can go on demand and execute a pipeline, and everything will be moved. You don't have to wait for the next cadence if there's an urgency. So we have developed that as well as one of the edge case where, if anything goes wrong, you could still run on demand and have things go on. If you go on to the next slide, Jagdish, this is what you see. This is as of October. We haven't taken a recent snapshot, but you could see that there is 2.34 terabytes of data volume that has been moved across the globe. The maximum traffic you would see is in Europe, EMEA region. That's where a lot of the file movement has happened. If we look now, maybe I would say it must have been more than double because we had the renewal season. So it
Yeah.
should easily cross maybe around 7 terabytes, in my opinion.
That's a
So
lot of data.
that's how you can see real time. This is how
Mm.
the application is being used and how much. And we have had zero failures since we went live on ADF.
Mm.
Uh,
Nice.
had no complaints, no downtimes.
Yeah.
Yep. Now we'll move on to the optimization and how we had a journey from our own solutions. And also, if I may step back very initially, like maybe a year ago or maybe before that, when we started off, we were leveraging Azure Service Bus, where we were posting whenever a file used to come, we used to post a message over there, and we used to read the message from there and then do it. So it was like one message at a time and then pick it. So it was kind of slow. So we optimized and we moved from there. Jagdish came in; he had a lot of review with us. Um, then we had our leadership be tell us that hey, we want to, while we are testing, or we want to do it like every minute. So when we were doing that, we saw that there was a cost that incurred, was like almost like, I would say, $4,000. I remember we did a cost analysis on that. We were executing maybe 60 pipelines at a time. So there was a lot of pipelines that were backed up, and they would wait. There would always be pipelines waiting to be executed. They would succeed, they would wait. So then we thought of this solution where we said, okay, the download part was what we decided to do. That let the users download from the transient storage, so we don't have to execute all of them at one. And we had a call with Microsoft. And we had many sessions where we talked about the cost of it, because we saw that the cost was going up. We were not able to achieve exactly what we were trying to, like, the user still had to wait for the file to be downloaded and all. So then we tried and understand the black screen that you see at the bottom is one of the things that we learned, how much it would cost us with the kind of volume and the bandwidth that we have. And we had issues where I'm just talking about the issues because how we resolved it is going to be the next. So earlier we were using self-hosted IRs. ADF provides us self-hosted IRs where we configure our own IRs and use them to move the file from one location to the other. In within the copy activity itself, we were using like maybe two IRs dedicated for each region. They were fine when the volume of the file was less, or when we were not executing as many pipelines in parallel. But when the parallel things came into play, and when we had volume, Jagdish himself was testing like 500 GB of files. I was loading more than 500 GB of files. When those things came in picture, we saw that the self-hosted IR was not able to deliver what we were expecting. We tried to increase the self-hosted IRs, but in vain. It was not helping. Then we moved on to auto resolve, which is nothing but Microsoft provisions on the fly on runtime. So let's say we normally get 50 GB of data, but now we are getting 50 GB of data files, and 10 times of the files that we get as of today. Microsoft, when we select auto resolve, Microsoft provisions based on the data that we are receiving more machines to work on. And then it also provides us the data integration units that we can utilize. So that was very powerful information that was at our hand, and we made use of it, and we were able to solve our problem. So if you look at that, the cost of DIUs is like 25 cents per hour. And when we were running it every minute, there was a cost of execution, and there's a cost of executing, and also the cost on the copy activity as well. So the amount of data that we move, the number of DIUs we use per hour, and the entire execution. So the orchestration charge is also included in that. So from that, so we had like minimum 2 DIUs, data integration units, that you could use, or you could use 4 DIUs. When you use 4 DIUs, even if we have 800 GB or 1 terabyte of file, we are able to move maybe from ranging from based on the bandwidth from 50 minutes to 1 hour. But a 100 GB file easily maybe in 12 minutes you are able to move. So that was the magic that auto resolve did for us.
Yeah.
Yeah. And if you talk in terms of cost, now it's like $4 that we spend. It's every 4 hours that we execute the pipeline. So it's like 6 times in a day. So even we calculate that, it's still like $4. So it comes to like $120 compared to 4,000. So
Yeah.
almost 190% of cost reduction that we had on
And that was
our.
all from the auto resolve switch.
Yes.
Yeah. Yeah.
Auto resolve, and then even reducing the number of times that we execute,
Yeah. Yeah.
because we made sure that the users have the information of the file where they want to download from, and they're able to download the file.
Yeah. Yeah.
Yeah. And on the right hand side is what the Azure Data Factory. It shows how the controlling and the scheduling and all it has. So we were able to schedule at regular interval. You can schedule in a different tumbling window and all that. But we ended up with every 4 hours, which helped us a lot.
It's a great story. How long did it take you to figure all this out?
So we started off, I think 2023 last quarter we started off,
Yeah.
almost around October, and we were ready with the solution. As I said earlier, it was about we were using Azure Service Bus and all. We were able to move the files and everything, but when we went for review with Jagdish and Shamit, we were talking about, how can we make it more better, why does the user have to wait and all. So when we were challenged with those particular situations, they said we need to pull our socks and make this more better if we have more files coming in. And then we had more edge cases coming in where you were talking about across the regions and all those things.
Yeah.
Yeah. So it was not a like a moonshot where we just came and did thing. It was very iterative. We were being challenged at every other iteration and every other step, and with everybody's input and help, we were able to deliver and come at this stage.
You've got to be pretty happy with this team, Jagadish. Yeah.
Thank you, Kasim, and Sridhar for sharing this. Hopefully, you found this helpful, all of you. I think the ADF has tremendous, power and the capacity. I mean, it's just a matter of, especially the Azure hosted integration runtimes versus self-hosted integration runtime. We couldn't believe the magic. We
Yeah.
couldn't believe the numbers when we saw initially. It's like, is it really moving the file? Yeah, so seriously, right? At 100 GB file, we were moving with self-hosted, taking hours. With Azure IR, it took 12 minutes. We said, you know what? No, there is some problem here, right? I don't think it has done it.
The max Jagdish I saw was 185 MB per second kind of thing.
Yeah, it was unbelievable performance, and look at the cost. We're not, breaking a bank. It's like from $4,000 to 120 a month. That's a drastic performance optimization. And I mean, that's the beauty of the cloud, right? It's like a genie in the bottle. You just had to tap it, and how you use it, what you use it for, and use it in an intelligent manner. So we always ask ourselves, is this meeting our functional requirements? Is it meeting our technical requirements, security, reliability, whatnot? And is it meeting commercially? Are we using cloud in a responsible way? Right. So this use case has been an eye opener, a tremendous opportunity to push a limit on one of the tools, which is Azure Data Factory. If you're interested to learn more, ping us, and we'll be happy to share more information.
Yeah, thank you so much for sharing this. And I appreciate going through the entire journey in the process too, because as Kasim mentioned, it's iterative, and
yes. And as we move further, I think we every time we run into some issues, we kind of overcome. I think ADF is a flexible framework, and we did reach certain limits, but I think it also has a lot of capability. You just have to have that iterative way of developing it. like that
Yeah.
parallel execution. That actually was a game changer. I imagine you have to code all these things, right? We did look at, okay, can we write a code and deploy it into function app or some Kubernetes to see whether we can do this. Nothing could align, or nothing even come close to as ADF was doing, especially with Azure hosted IR. As I said, we couldn't believe it, right? We really downloaded a file to see whether it actually moved the file, right? Because it was shocking for a few weeks to really, and now we don't even think about it.
Yeah. That's probably my favorite part of the story. I mean, every once in a while something happens and you're like, is that an error? That's too good. That can't be, that's just not working, right? But yeah, that's
Yeah, I think one thing what happened is because you're moving from Azure to Azure, right? That's why, because it's not coming to our MMC once, so that is the reason it might be faster, right?
Yeah.
No, even though with the self-hosted IR, even though it is in the Azure, right? It had a different magic. I mean, I don't know, something, it has been highly optimized, right? We don't know, that's a Microsoft secret sauce, right? Though we run the same instance in the auto, what do you call it, self-hosted integration runtime.
Yeah.
The magic, what it was happening on Azure hosted was, we couldn't believe it.
Yeah.
Because even Sridhar, the IR, self-hosted IR is still in Azure, right? It's still
Yeah,
the
but
same.
I think because of the cores, right? Number of cores.
Yeah, whatever that is, right? I think it's the self-hosted IR versus the auto-resolve IR.
Yeah.
Auto-resolve IRs are highly optimized, highly scalable. And
Yeah.
the beauty is you're not, spending a lot of money on that, right? It scales, it does the fantastic job, and it goes back.
Yes, that's the best part.
Yeah.
So
I'd
that's
love to hear it.
the serverless kind of you don't think about the computing. You have an army of capacity sitting there. You just execute it for a short duration time, achieve it, and you are done with it. We couldn't scale it within our own self.
Well, thank you guys so much for coming on and sharing. I know you're going to be coming back soon with a new story, so I'll look forward to that. And we'll get those links in the description. And thanks so much, everybody.
Take care, everyone. Bye.